it's part of the conference after all that. So without further ado, over to Seb.
Thank you very much. So the first thing to point out is actually it's bad test, good test. And it's just a slight nuance difference there in that there's an awful lot of bad tests that get written, and I'm hopeful that when we get to leave here today, you'll have an idea at least of what I believe makes good unit tests. But before I start, I would like you to just stop and think what makes a unit test good or bad. Right? So I'm assuming that most of you here work in development or have worked in development in some capacity. Is there anyone here who is absolutely not a developer? A couple, okay, a few. So there's not a lot of code in this session, but there is. Well, no, actually, there is quite a bit of code. So, but there's also going to be you'll be able to hear me waffle on quite a bit as well. So you may get something out of it. I hope you get something out of it. It's really aimed at developers. So I want you to think about unit tests. I want you to think about what is a unit test? What would make a unit test good or bad? What pain points have you had using unit tests in your development practice? What benefits have unit tests given you? And I'm going to be quiet now for about a minute, and I want you to really think about it. Oh, dear, that was what's it. So I would like you to think about 3 things that are good about unit tests in your experience, and 3 things that have caused you pain or are bad about unit tests. I say here, write them down. If you have a pen and paper, go ahead and write them down. Because, concrete examples, concrete actions, focus the mind. That felt like a long time, didn't it? That was actually only 50 seconds. So I even shortchanged you by 10 seconds. And so we've been thinking about unit tests, but before starting, let's have a definition, or at least some volunteers from the audience to come up with statements of what they think a unit test is. So over to you. Anyone like to chip in?
I see unit test as a description of a unit of behavior that we can, which is automated, so you can run and verify that it actually works.
Sounds like a good statement. Any others that add to that or contradict it?
It's an implementation level test that runs fast.
I like that one as well. Let's have one more for completeness. Something this side, please.
Executable specification.
Executable specification. Right. I like the direction this is going in. I'm going to talk about some properties of unit tests. So the things that we've talked about here in unit tests are all, they're all correct, they're all true. But beneath that, there are different ways of writing executable specifications, different ways of writing things that exercise implementations or exercise them fast. I believe that there are this list of 6 properties that you should consider apply whenever you consider whether a unit test is good or bad. And I'm going to go through them one at a time. I'm going to show examples of what I think are good and bad, tests that contradict these principles and tests that align well with them. And please, at any time through the session, if something's not clear, if I'm talking nonsense, chip in and ask a question, and tell me to explain. So first off, I think tests should be understandable. So I think that plays directly to the gentleman at the back who talked about executable specifications. The tests there are primarily to make sure that your software does what you expect it to. And if you think of it just in that sense, then you're going to get some benefit from it. But think about the people that come after you. Think about the maintenance engineers or the people that are going to have to pick up your code base in 5 years' time. They're going to look at both your code and your tests, and try and work out what the hell you were thinking of at the time that you wrote them. If you're not convinced by that, in 2 weeks' time, you're going to have to come back and look at it. I've often sat with people and they've been showing me their test and they go, why did I write that? What's that all about? So, it needs to be understandable. You need to know why you wrote the test. You need to know what the code was supposed to do in the first place. And you need to make sure that it serves more than the one purpose. So code and tests get read far more often than they get written. And so understandability is right at the core of that. So things, things that pop up straight out of your head. What would you have to do? What are the key bits of a test that make it understandable?
A good name.
A good name, excellent.
Not being too long.
Not being too long. Okay.
Clear assertion.
Clear assertion.
And
Plain English. Yeah.
clear structure to each test.
Structure to each test. Yeah. So I asked questions at the beginning that was a bit slow, but as you saw, when I asked about understandability, people reeled them off very quickly because this is actually core to development, so it's not just about unit tests, it's core to writing code of any sort. And things that I've made little notes of here that I think is worth considering, certainly when we think about the unit test frameworks that a lot of us are using, is locality of reference. So these frameworks often come with potentially class hierarchies of test suites. They come with setup methods and teardown methods, and all of these things give you a great deal of flexibility and power, but when misused, they can spread the understanding of the test throughout your test suite. So one of the things that I actually advise many of my clients not to do is to make use of your setup method for setting up test data. When I come to a unit test, I want the name to tell me what the test is, what behavior the test is validating, verifying, but I also want to be able to see the full context of the test. I don't want to have to jump to the head of the file. I surely don't want to have to find another file or another class, or base class that has got some setup methods in it. I want to see the context there. So this does not contradict, I think, what somebody else said, there need to be small tests. It doesn't mean that it all has to be in line. So I'm lucky, or maybe unlucky, to have Steve in the audience today. So if you haven't read the Growing Object-Oriented book that him and Nat wrote a few years ago, I highly recommend it. But what they do a lot of is take small bits of functionality and extract them into utility methods and give those utility methods a really good name. So you can read, your tests still stay short, but as you read through them, they tell you exactly what's going on. Whereas if you've got all of that set up in a setup method that isn't particularly clearly referenced, you actually have to go and look at the setup method to find out what it was doing. So this advice is about having a locality of reference, being able to understand what the test is doing without having to jump around in the code base. Equally, I think if you see the number 3 in a test, what does it mean? Yeah, so quite often, in fact, I was looking at a client's code just this week in fact, and it had the number -3 as a parameter to one of the arguments. I said, what's that -3 for? Would -1 still pass? They didn't know. So the message here is, please don't use arbitrary values. Use symbolic constants, something that gives the person reading it some reference about why you thought that was a useful number to put into this verification in the first place. And so, on to some examples. So all the examples that I'll be showing today came from the wonderful resource known as GitHub. So they're all real code that people have written at some point and thought might have been a good idea. Would anyone like to volunteer some interpretation of what this might be trying to verify?
The period is lasts for 4 hours. It's a period object and it's trying to...
So, what's the name telling us? So, yeah, so maybe something scales. Why 4? Why is there, is it important that it's 4? Would it be the same if we replace 3 throughout? The point here is that I would suggest that even the guy who wrote this, when he comes back to it, is going to wonder what's going on. There's nothing here to get your teeth into. It's longer than you would like. It's not clear which bits are the setup, which bits are the action, which bits are asserting. There are asserts here, but are they all important? Why are we getting get end is greater than or equal to 0? I mean, there's just so much going on, and there's nothing clear about this. How about this one? Sorry? Woohoo, exactly. So this one, I think that the title, you can possibly improve on it. You might not like this naming style, and it might not conform to your naming conventions, but you read it and it goes, ah yeah, I think I understand what's going on there. There's a clear context action outcome, which equally you can talk about a range of act and assert. Personally, I don't like commenting these sections. I think that should be, white space can be your friend, but it's short, it's concise, it's to the point. How about that? Is that better or worse?
Redundant really, because the name.
Sorry?
It's redundant really, because when it fails, if it fails,
Yeah.
the name will tell you what went wrong anyway.
So that's a fair point. So essentially what we're doing here is we're passing extra arguments into the assertion method, which allows you to comment things to give more context to when the test fails. So typically you're going to want your unit test running as part of your continuous integration build. Typically you're going to want them to run fast. If they fail, you need to go and fix them quickly. You want to be guided by your test directly to what went wrong. So in this particular case, I agree that this extra piece of text may not add anything. But there are many situations where, especially if you have more than one assertion, where the textual parameter to the assert, to the method on assert, can be really, really useful to guide you to what went wrong. So give as much output to help you for when it goes wrong, because when it goes wrong, aren't going to want to muck around and try and work out what's going on in the debugger. So that's understandability. Does everybody understand? So move on. So this one's maintainability. One of the main things that I find when I speak to clients about, oh, we tried unit testing and it doesn't work here, is because they have built a lot of tests and then they were responding to change, and they found that all of their tests broke, and they had to go and do large amounts of work to try and get their test suite running again. I've actually heard someone say, yeah, unit testing doesn't work with Agile, okay? because it slows you down and it inhibits your ability to respond to change. And so my response to that is no, it's the way you wrote your tests that are causing the problem. So test codes are not just tests. So we've already talked about them being documentation. They're part of your code base, they're part of the specification of how your system works, and I think you should treat them every bit as lovingly as you treat your production code. So you should apply maybe not exactly the same heuristics, but the same quality number of heuristics to your test code as you do to your production code. You should certainly, if you have do pair programming or you have code reviews, you should be reviewing the tests as well. They're just as important as the code. You should apply the same solid principles to the code. So if you start seeing duplication, extract it and put in a utility method. If you start seeing magic numbers, as we've already talked about, take them out and use symbolic constants or something like that. There's also an issue around what flavor of how you test, for instance, algorithmic things. So I sometimes see tests where there's a calculation in the test which exactly mirrors the implementation in the code. So essentially all you're doing is validating that your test does what your code does. This is not very useful. And this becomes more of a problem in some situations where people are over-reliant, for instance, on mocks for setting up interaction-based testing. The idea of these tests, from my perspective, is to make sure that your components, your units of work are doing what you expect them to do. So we're talking about here about the specification, we're talking about behavior. We're not talking, oh, it should call this service, then it should call this service, and then it should respond in this way to this value coming back. Certainly, you certainly don't want to be coming to a method that you want to test, looking at the code and then putting in tests that correspond to bits of code that you see. So this would be one of my arguments to customers about why they should be doing test first or test-driven development rather than test after. So the main reason for doing test first or test-driven development is if you're doing test after, you probably aren't going to do any testing. But once you've got over that particular argument, it's to do with test your expectations, test the behavior of the system that you're building, don't test the implementation, because the implementation should be able to change freely. So, some examples. This comes from obviously an insurance domain. We've got customer, and we want to make sure that a smoking customer requires a manual referral. So maybe we have to check with his doctor or something like that. Does anyone see any problems with this or any issues?
Yeah, lots.
Okay.
I think the setup of the customer is obscuring the real challenge, so we'd better off with some sort of build of the customer.
I agree completely. Did everyone hear that?
Yeah.
Right, so, do you want, please, you
All
said
right.
it so well, say it louder.
I mean, for me, in that test, the setup of the customer obscures the real intent. So if we could provide some sort of a builder pattern that would make it very explicit that this is a customer, where actually all the details like the name of the or probably the date of birth are probably relevant for this test. And what is relevant, which I can only guess, is the yes. One of the parameters.
Well, it could be the no.
Yes.
Well, absolutely, yeah.
And so, to underline this, I will do a quick change to the next slide, which is non-smoker does not. And so we can play back and forth. You get to see what's relevant, but you get to see why this gentleman is absolutely correct about this test. So here's the builder pattern, or an implementation of the builder pattern. And this is something that is useful in so many domains. Again, well documented in many places, including Steve's book. So what you do is you create yourself a utility class that constructs maybe one object, maybe a whole graph of objects, because we deal with complex interactions between data. But it creates it using some sort of symbolically named method, which is understood by the development team, and if you're sharing this with your stakeholders, then in business domain language. So that would build you a standard smoker person or non-smoker person, and then you actually have separate methods which modify that standard default data object. And then you go build, and it does whatever it needs to do, whether it builds it in memory, puts it into databases, sends messages over the wire. So this being a unit test, we'll talk later about whether it should be going into databases or going over the wire onto the file system. But nonetheless, the point here is that you have some other object or class that you delegate responsibility to for building your data, and then you explicitly say what's important about this data. So you have to have some discussion with your team about what constitutes a normal entity or an uninteresting piece of data. So for instance here, we've got the customer builder. We're saying we want a standard single mail, and that's it. The build generates that object for you. Here, we can see now that this is a smoker person. And so it's very clear. As soon as you go to the test, you don't have to wonder whether it's the yes or the no. You don't have to wonder, is it important that the guy's 23 or 37, date of birth? It's very clear. This is the only thing that's important here. This is the only stuff that's going on in the arrange bit, and that's the only bit that changes.
Excuse me.
Yeah.
There is a different pattern that we use to get around this problem.
Uh-huh.
I wonder what you think of that. If you could go back to the original example. We would tend to use fake variables called fakes for all the stuff which isn't important. And then the stuff which is important, we leave in as a constant string in the test. So it's quite clear that it's quite clear which are the important parts that you're passing in.
So the reason that I prefer the builder pattern to that is that you actually have the locality of the creation of your data in one place, which is your builder, rather than spread among all of your verifications, all of your tests. So if you change the API, so if you had another argument here, you don't have to go through and add more fake data to every custom constructor. You just go to the customer builder and add it there.
Mm-hmm.
So it gives you, so there's nothing wrong with doing like that. So it achieves some of the goals that we're talking about. But I think if you, again, it's a do not repeat yourself sort of stuff. You find using the same pattern of fakes in test after test, well, then why not extract it and put it into the builder? So this one, it says down here, repeatable. And so lightning is because one of the issues that you see in a number of continuous integration builds is flickering tests. And I don't know how many of you are operating in a continuous integration way, but I hope most of you, I hope all of you. And the thing that kills continuous integration is when you can't trust the results. So if you come into a development shop and you go, let me have a look at your CI dashboard, and a build is red, and you go and you say to the person, well, why is that build red? And they go, well, it sometimes happens, but if you run the test on the desktop, it always works, and if you run it on its own, it works. So, you know, this is a bad thing. The idea about continuous integration build is that when it fails, it's failed for a reason, and that reason means that something's gone wrong, and that the whole team will drop everything until they've got the build green again. And so flickering tests really, really kill this. It means that you cannot rely on your build to give you the messages that you need to drive you to fix problems. And what happens after that is when you start not worrying about a red being there, a fail being there, then actual real fails that aren't part of the flickering fail start creeping in and you don't even notice. And one day turns into a week, turns into a month, which turns into a year, and you suddenly got an integration nightmare and none of your tests work. So I was in with a client last week, and so I said, show me your integration dashboard. And I said, there it is. I said, but that build's failing. I said, it's not failing, it's partially succeeding. It has been partially succeeding since May. Okay? This is not continuous. The continuous part of continuous integration is important. So, can anyone see why this might be a flickering test? There's plenty else wrong with it, by the way.
Sometimes the last one you might roll the same thing.
Exactly. We're saying, well, you know, each time you roll 5 dice, this should be different. Well, statistically, every now and then, if you roll 5 dice twice, they'll come up with the same set of numbers. So this is, you know, this is a bit of a contrived example, I know. Nonetheless, it's a contrived example that I really did pull off of GitHub. So it's not, I guess, that contrived. But you can get flickering tests. Now, a lot of things that cause flickering tests are environmental. And this is something that we have to work to overcome in our acceptance tests and our integration tests. But here I'm focusing on unit tests. And this is another of the reasons, and we'll cover some others later, this is one of the reasons why you should not be interacting with your environment in your unit tests. So Michael Feathers, who I think I'll be name checking with his book later on, Michael Feathers talks about the things that are not unit tests. He did it in an email or blog post a number of years ago, and he enumerates, he says, things that talk to a database are not unit tests. Things that talk to the file system are not unit tests. Things that talk over the network are not unit tests. He goes on to say these tests have value, they're just not unit tests. And that's because these environmental things like databases, networks, file systems, they have their own issues. So they may fill up, someone may change the permissions, the network may go down, someone may be transferring large YouTube files when you're trying to run your unit tests and change the performance characteristics. These are things that, because it's your code interacting with an environment, they're by nature integration tests. So, and the biggest single culprit that I see is databases. So I see unit tests that interact with databases all the time. And not only do they cause the sort of the issues I was talking about, but they also slow down your unit test speed. And we'll talk about speed of the unit test speed later on. So, correctly spotted. Any other questions about flickering or repeatability? Okay. Oh, okay.
Yeah, what about if you have a fixed seed for the random numbers, so that it's always the same?
Yeah, so absolutely. So there are ways around it. Yes. If you can make it so it's not potentially flickering, then then it becomes good again. So necessary. This is so this is somewhat subjective, I guess. It's how many tests do you need? What's the purpose of tests? Ken Beck's got a quote that he's hunted around which says something along the lines of, "I get paid to deliver code, not write tests. So I only write as many tests to get me to the level of confidence that I need for my customer." Anyone got any ideas about, how do you decide how many tests you're going to write? When is enough enough?
Depends on the consequence of what happens at the time.
So it is to some extent context dependent, yeah. This is one of the reasons why TDD is such a powerful technique. You don't write any code unless there's a test that drives it out. You don't write, so you sometimes write triangulation tests, so I'm not going to go into the details here today, but so you do sometimes get to a point where you can have a discussion after you've written the tests about whether maybe one or two of them can be removed. I think the important thing in that discussion is to realize that just because you wrote a test yesterday and it was very valuable yesterday, it doesn't mean it's going to be valuable tomorrow. So as you evolve your code, as it iterates and you change things, maybe some of the tests are no longer relevant. But necessity is an important characteristic for the maintenance, so it interacts with maintenance. If you have too many tests, or several tests that cover the same sorts of behavior, then you are increasing your maintenance burden in the future if that behavior changes. You're also putting more tests into your test suite, and so even though they're already very fast, still two of them is probably going to be half as fast as one of them. So eventually just the sheer numbers can overcome them. I do have a little example I'm gonna shell out from here, but this is another another GitHub project that I think is rather good. So it's I think it must be a school or college project where you convert Roman numerals with M, B, X, I into decimal, and the guy has obviously got a very odd idea anyway, because what he's doing here is he's taking a string of Roman numerals, he's converting them into Roman ones. Now, that seems very odd in the first place. Then he's counting, he's repeating creating a string with a number of i's in it, and then doing string compare to make sure they're two the same. So this possibly isn't the way you would go about testing this anyway, but bear with me just for a second. Yes, because the code is unfortunately a little bit worse than that. So this is the code. That is the string. This is the code. Well, there we go. Can people read this or not? So you see this region test case here. So you have to ask yourself, are all these tests really necessary? The first time I gave this presentation, I thought it was quite funny that he stopped at 3,999. There's a lot more numbers out there. But actually there's a very good reason for that. Do we have any ancient scholars in the room?
It's the biggest number you can represent.
It gets very strange after that, doesn't it?
Yeah, so up until I think 200 or 300 AD, that's as high as they could go with them. And then they started inventing some more. At least that's what I've been told. So I think that one is an example of a number of tests that were, just not necessary, unless of course he was testing a switch statement, at which point you have to wonder about the implementation. Okay. Another rather granular, brainy picture. So granularity. How much behavior should you be testing in any given unit test?
As little as possible.
As little as possible. So a single behavior. So in the same way that we can have discussions about how big is a unit, we can also have heated discussions about what constitutes a single behavior. But nonetheless, a single behavior is the aim, because when a test fails, You want to know exactly why it failed, what the reason was that caused it to fail, and you don't want it to possibly fail for 1 or 2 or 3 reasons. Another motivation for not having multiple, asserting multiple behaviors in tests is that quite a lot of test frameworks stop executing the test as soon as they hit the first failure. So you may have more than one failure, but you only find out about the first one. Then you fix it and you go back, and then you find out about potentially other ones. So granularity, keep them small. So this is, you get the same pushback on granularity as you get on splitting user stories into small user stories. And that people go, well, it's overhead. It's the same setup that I'm doing in both tests, so I should just do it at once. It'll make the test suite faster. And it'll minimize my maintenance overhead and things like that. And all of these things are they seem on the surface to be reasonable, but actually they don't work. You need, if you've got repeated setups, we'll take that setup out and put it in a separate utility method. It shouldn't be an expensive setup in a unit test in the first place. You want to validate a single behavior, verify that it behaves in the way that you expect it to, and each test verifies a single behavior. So I don't take it as far as maybe some people do and say there can only be one assert. So there may be more things that are going on in your test that the behavior than one assert can cope with. In general, that's not the case. In general, a single assert is the ideal to aim for. If you're going to have more than one assert in a test, start with the more general and then move towards the more specific would be my advice, so that you get the feedback early that something is significantly wrong. So I'm going to go back to this test rolling method from the Yahtzee game. So we've talked about this, the flickering nature of rolling. What about any of the other bits of this test? Anyone want to comment
At
on
least
that?
3 different tests. Variable y isn't used past the second line.
Yeah. So basically, that's the point. We can argue about whether these as separate tests would be valuable, but certainly having them all in the same test method is not useful.
The other problem is that assert equals.
Sorry?
That the first assert equals y.
Yeah.
That there's going to be 70,000 different possibilities or something. So if that comparison operator was bad, you wouldn't find it until the 70,000th run.
So there are many things that are wrong about that. Your assertion operator, depending on how you're building up your assertion operator, it's probably going to be asserting on equality of, is it going to be asserting on equality of dice orders? There's all sorts of things that you could drill down into, and so there are actually many other tests that you will have implemented before you ever get this far. But just actually putting all of these together, it obscures every single one of those tests, and it doesn't add any value. And last but not least, tests should be fast. Unit tests should be fast. So in the TDD cycle, in the continuous integration world, what you're trying to do is you're trying to get feedback quickly, so that before you start thinking about something else, or go off and have a cup of tea, or go home for the weekend, your build is green. And so the unit test is the first safety net that you get. The first time, if you're in a compiled language, I guess it's the second safety. But assuming that your code all compiles, it's the first validation that your code works in the way you expect it to, and that you haven't introduced any regressions. And you want that feedback quickly. In many environments, you should be running these tests on your machine, on the developer machine, before you check in the first place. Depending on your CI environment, you may have some sort of pre-commit stage that runs the tests when you push them up to the server, but before it gets integrated. But nonetheless, you want that feedback quickly. We're talking seconds rather than minutes, so we need to keep the test fast. So if you see a wait or a sleep in your unit test, then you want to rethink what you're doing. It's probably not a unit test. Move it out of the unit test framework. If your unit test suite ever gets slower than, and I'm going to just pick a number, 5 minutes, think about what's happening. Do you want to partition your solution into several components? Just test one component at a time with its own unit, with its own set suite of tests. So there are several ways of trying to address it, but you need to address it, because if the unit test runs slowly, then developers will run them less often, or they will check in less frequently. And if you check in less frequently, then you have more to integrate, and so you have a bigger chance of conflicts with other people. So this is actually crucial to unit test speed work. Now, again, benefit of having Phil Nash sitting here at the front. So I'm going to just mention the word C++. Okay, and C in the same sort of breath, I guess. In that it's a compiled language, and the compilation phase in C++ can be quite slow. Your unit tests can therefore depend on the compilation succeeding. If the compilation takes too long, then by its very nature, the unit tests are going to take whatever time it takes them to run and the compilation to run. And at that point, with technologies like that, you really do have to apply some significant brain power to partitioning it successfully and keeping the unit test run down to a manageable level. And partitioning is your friend, divide and conquer. Phil, do you have any other concrete advice about keeping C++ unit tests fast?
Tests are normally the problem. C++, they
Yeah.
run pretty fast. So it's a combination stage. So keeping your source level dependencies minimum, things sorted out.
So just in case you didn't hear at the back, it's make sure your dependencies kept under control. So proper architecture, proper partitioning of concerns, componentization essentially. So those are the six. The six on the next slide. I see 7, I think, but there you go. I can't even count. I should have unit tested this presentation. So these are the 6 properties that I think are very important when we come to writing unit tests. Other people have maybe other observations on unit testing and testing in general. So Emily Batch has got a list, I think, of 5 that some are the same and some overlap. Roy Osherove in The Art of Unit Testing, first edition, identified 3 principles of unit tests. But in the nature of the business that we're in, things just keep getting bigger, better, and faster. So in the second edition, which he's writing at the moment, he's got 9. So he's winning on that at the moment. So I would like to have a think about what the thoughts that you had at the beginning. Maybe you wrote them down, and maybe feedback to me if you have any observations about how did your good things align with the 6 properties that I've just talked about, and did some of the bad things, were they bad because they contravened some of these 6 properties? So did anyone actually write them down? And does that work? Yeah, please.
Yeah, one thing I've got down here that wasn't really on the list was that unit tests, test-driven development, I suppose this is about, really, not about unit tests, can help create more modular, cleaner code, because you're keeping, it's a smell if your test is getting too big and too difficult. It makes the code that you end up deploying is good. So we see that as a benefit.
So I absolutely agree so I like working in a test-driven way. This specifically, however, I didn't want this presentation to focus on TDD. I think it should become clear as we go through that I believe it's the right way to go. I think it does help you with your design. It does certainly give you smells back about how easy it is to set up your tests. But a lot of places, a lot of teams, they pick up on TDD and they see the red-green refactor, they read the books, they drink the Uncle Bob Kool-Aid. But underneath the red-green refactor cycle, they are still building a suite of tests that are inherently unmaintainable and potentially slow. And that actually leads them to the place where folks say unit tests and Agile don't work together, because it leads them down the road of building a large suite of unit tests that they can't maintain. So I mean, back in the dawn of time, in last millennium, I was working on a requirements application, and it had an internal scripting language, and we had built a huge suite of unit tests that were driven through this scripting language. But there was a version upgrade, and the scripting interface API changed, and this large suite of unit tests stopped working. we had a tight deadline, we didn't fix them, I left the company, I came back 10 years later, they still haven't run. So there's definitely, it's really important to keep these things up and running, and the trouble with greenfield sites in general, and just doing unit testing without having any guidance or at least any experience of doing it, is that you can end up in a place where it was looking really, really good until it was really, really awful. And that's the nature of generating a legacy code base. So this is why this talk I'm really focusing on unit testing principles that can be applied whether you're doing test first or test at the same time or test after. These are the things that will help keep your unit test suite maintained.
One tip, if your tests are too slow, try to run them in parallel.
Yeah.
And then normally you will discover some odd flickering or something like that. When there are some database tests as well. And you have to move them in another profile, for example.
Yeah. So personally, I can see, I've worked in organizations where we've run our acceptance tests in parallel. I've never yet had to run unit tests in parallel. It feels to me like, well, maybe I just haven't worked on those code bases. So I take your point. If the unit tests aren't running fast enough, then maybe you can spin them off into separate environments. But the real idea about having them running, you develop a test stop before you check in, it feels to me like we're going too far. There's something else going on.
Yes, you can switch it back afterwards.
Yeah.
It's only to detect the tests that are.
That's the point, just to detect issues with your tests.
Oh, I see. Not for making them run faster, but to detect linkages between them. Okay, no, fair point. I'm hoping that some of the other practices that are being adopted, such as code reviews and randomizing the order in which unit tests run, will also pick that up. There's someone at the back there.
One thing I wrote down was completeness of tests.
Yeah.
And it kind of goes to that attempt to make the Roman numerals, that huge table of what those Roman numerals ought to be, and also that YATC, the quality operator, couldn't possibly have tested all the possibles.
Yeah.
And I have a personal horror story of writing a date library that turned out that it didn't work out just after a leap year, and we only didn't find that until we hit the leap year. And it's sometimes you want to actually exhaustively test every possible combination, and that obviously makes things slow. But is there, I mean, like, just to take that Roman numeral example, I mean, how would you test it that it did actually produce the right Roman numerals in every possible text without doing an exhaustive test?
So you never, sorry?
Surely that, like in that case, that's physically impossible because, like, to test everything, you'd have to go to infinity.
Well, you can test all possible dates for these.
Yeah, the Roman numerals, they stop at some point.
Yeah, up to 3,900.
So the answer is doing anything in the world is risky, and what we're trying to do is mitigate risk. And what you're going to be doing, especially if you're working through a TDD sort of way of working, you'll be introducing behaviors as they get validated one test at a time. You won't introduce any functionality that hasn't got some sort of check on it. And then by implication, the operations can be chained together or behave in some sensible way when you make more complex Roman numerals for that example. And you maybe have a couple of tests that you think of edge cases, or you try and chuck in too many ones, or one before and after V. So you think through these things, and you use your knowledge of the domain, because as we know from the keynote, all developers know about the domain and have to understand what's going on.
Yeah.
Yes.
I have a comment on that.
Okay.
So I think the nice way to think, not falling into the trap of being obsessive about what you're testing, is to do the outside-in. Previous talk was talking about external quality, internal quality. So if you start from the external quality, what is vital and critical for the business here? Do you need to know if it's banking, it's financing? Probably have all the rules that specify that acceptance test. It will cover everything. But when you go to the inner quality, when you go to unit tests, I see that more as a description of the protocol they established between objects. So what you need to test there is the input and output is what you predict the objects to be. So you're not obsessive about testing every single thing. You're just driving your
object
There are
construction.
cases like in Roman numerals and date calculations that there are lots of evil edge cases, and the result is not terribly easy to describe.
So
Other than
evil edge
actually writing
cases
the
is your domain, and exhaustive, however, isn't. So I mean, you do need to understand domain and where the edge cases are. So I would expect in integer arithmetic, you want to think about overflows, for instance, might be something that will crop up. In the Roman numerals, it is possible if you only want to test between 0, 1 and 3,999. You could write exhaustive tests, but in most domains, exhaustive tests are beyond the capacity of the universe. I'm going to not talk about this very much longer, but I want to direct you then to a book so you can go and have another wee look at that. There's a book by Jerry Weinberg called Perfect Software and Other Illusions. It's a very amusing book, but it's also a very important book because it grounds this discussion in the concept of trying to gain information about what you're writing, not to try and make sure that it's bug-free. So you're trying to work out, does it work as we expect it to? We will never be able to guarantee that it's bug-free. Modular formal proofs and all these wonderful things that happen in universities sometimes.
I was wondering what your opinion is around metrics like coverage that you can gather on unit tests.
Treat all metrics with care. So metrics, who am I thinking about? Tom from Norway.
Gill.
Tom Gill. Tom Gill talks about metrics a lot in his work, and he says if you can't measure it, you can't do anything with it. So this is fair. It's a fair point. You have to get something objective because subjectivity isn't very helpful. However, there's also the idea of gaming the system and the law of unintended consequences. So if you set an arbitrary coverage or line coverage target for your developers, you will hit that target, but your test may be rubbish. So you can get 100% coverage without a single assertion. So what are you trying to what are you trying to achieve with your coverage? Equally, what you can do in some CI environments, some systems, is you could track the trend. So if a check-in decreases the line coverage, then that may be an indication that there is a smell and you need to look at it. You can use ratcheting so that you start with a particular coverage and then each check-in you would like to see the coverage go up a little bit. All of these things can push people in the right direction, but metrics themselves or hard targets can be counterproductive. I'm not sure whether there's anything in the .NET world, but in the Java world there's an interesting tool called PI test, which is a mutation testing framework. Mutation testing aims to help us work with coverage.
There's one called PEX, EDX in .NET world.
Okay.
Yeah.
So I mean, out of interest, how many people have heard of mutation testing? How many people are actually using it in their day job? Yeah. So mutation testing actually has been around for decades in academia. It's only quite recently that there have been tools that have become performant enough. The idea with mutation testing is you don't look at coverage of unit tests. What you do is you take your code and it automatically and heuristically injects defects. So it changes greater than comparisons to less than comparisons, and then it runs a unit test. And basically what it does is it introduces a mutation, runs a unit test, and if the unit test now error, the mutation has been killed. If the unit tests don't error, the mutation has survived, and your unit tests have not got sufficient coverage of your code. And it makes sense. The trouble is, there's a lot of greater than and less than statements in your code probably. There's a lot of control points, and so it takes time. So the heuristics around expanding the possible solution space and then narrowing it down to something that could actually execute for the heat deck of the universe is a non-trivial problem. How long have I got?
You're over, but you're fine.
Sorry?
You're over.
I'm over. Okay.
You can keep going. These guys, you've got lunch next, guys.
Okay.
It's your time.
So I will back you off quickly. I'm sorry to keep you. So none of this is a substitute for writing testable code. So we can write good unit tests, but if the code is hard to test, the code is hard to test, and we need to do something about that. And so I was going to show an example. This is a quote from Brian Marek, another person that's worth having a look at on the web. One of the really, really fundamental things that TDD will help protect you from is having dependencies, introducing dependencies that you didn't realize you were introducing. So here what we have I think this is a bit of C#, is we have datetime.now. So you, as a developer, might write this, go datetime is a wonderful class, it's provided by the library, now tells us the time now. However, as soon as you've written this, it's going to be very hard to test this, because datetime.now is a system call, essentially, so it's a system call. So what you can do is, when you write this test about when the price rise should happen, you go, oh, how can I set the date, so just before the price rise and at the price rise and after the price rise? And the answer is, well, you could go and change the system time. And that's probably not the right answer. So what we can introduce is we can use dependency injection or inversion control and create a clock, or a system clock interface, wrap the concrete production implementation of the system clock around the datetime.now, but create a test implementation that you can inject this all the time. And then you get to the point where you can control the date, you create your system clock, and you inject the clock into the price calculator. So this is something that I'm sure a lot of you will be doing all the time. The issue, I guess, is that if you do test afterwards, you will then probably find that you've got some of these dependencies in your code, and you will have to go and refactor them. Whereas if you do test first, as you're writing the test, it becomes clear you need to control the date. So I don't know what you plan to do this afternoon. I would go to John's session and do Cyber Dojo, because you will be working with his wonderful web tool, writing unit tests, actually doing TDD in an interactive environment. And if you don't go to this afternoon, then go online and play with it later. It's cyberdojo.com. So those are the purposes of unit testing. We leave you with these thoughts. Unit tests are your executable specification, so treat them with as much love and care as you give your production code. And Michael Feathers is another, as I said, I was going to name check him. Wonderful book, especially if you're working with legacy code. And his definition of legacy code is code that has no text. And so, hands up, who's working with legacy code? By the way. Thank you very much. It's been a pleasure.